Question 28. The graph of the circle x squared plus y squared equals 2 is shown. The interval connecting the origin O and the point 1, 1 makes an angle theta with the positive x-axis. Part A. By considering the value of theta, find the exact area of the shaded region as shown on the diagram. To find the area of the shaded region, we subtract the area of the right-angled triangle from the area of the sector. But to find the area of the sector, we need to find the value of angle theta first. Consider the right-angled triangle. The hypotenuse starts at the origin and ends at the point 1, 1. The length of the horizontal short side therefore is 1, and the length of the vertical short side is also 1. So we can use the tan ratio to find the value of angle theta. So this side is the opposite, this side is the adjacent, and tan theta is opposite over adjacent. So 1 over 1 is equal to 1. So we can form an equation, tan theta is equal to 1. Taking the inverse tan of both sides, we get theta is equal to pi over 4 radians. And pi over 4 radians represents 1/8 of an entire circle. So the area of the shaded region is equal to the area of the sector minus the area of the triangle where the radius r is equal to the square root of 2. So the area A is equal to 1 over 8 multiplied by pi multiplied by the square root of 2 squared minus the area of the triangle, which is half times 1 times 1. So that's half base times height. And that equals pi over 4 minus 1 over 2, or 1 over 4 multiplied by pi minus 2 in brackets, square units. Part of the hyperbola y equals a over b minus x minus 1, which passes through the points 0, 0 and 1, 1, is drawn with the circle x squared plus y squared equals 2 as shown. Part B. Show that a equals b equals 2. The first thing to note is that the hyperbola y equals a over b minus x minus 1 passes through two key points. The first point is the origin, which has coordinates 0, 0 and the point 1, 1 on the circle. And we can use that to find the values of a and b by substituting the values of x and y from these 2 points into the equation and then solving for a and b. When x equals 0, y equals 0. So substituting 0 for x and 0 for y into the equation, we get 0 is equal to a over b minus 0 minus 1, and a over b minus 0 is just a over b. So the equation becomes 0 equals a over b minus 1. Adding 1 to both sides of the equation, we get a over b equals 1. Multiplying both sides of the equation by b, we get a equals b. And that satisfies the first part of the question. Now when x equals 1, y equals 1. Hence 1 equals a over a minus 1 minus 1. Notice that I've replaced the b with a since a equals b. So it makes it easier to solve for one pronumeral or one type of pronumeral. Adding 1 to both sides of the equation, we get a over a minus 1 is equal to 2. Multiplying both sides of the equation by the denominator a minus 1, we get a is equal to 2a minus 2. Subtracting 2a from both sides, we get negative a is equal to negative 2. And multiplying both sides by negative 1, we get a is equal to 2. Therefore, a equals b equals 2 as required. Part C. Using parts A and B, find the exact area of the region bounded by the hyperbola, the positive x-axis, and the circle as shown on the diagram. The area of the shaded region is found by finding the area under the hyperbola y equals 2 over 2 minus x minus 1 from x equals 0 to x equals 1 and adding to that the area that we found from part A, which is the area of this half segment, which is pi over 4 minus half. So the area is equal to the integral from x equals 0 to x equals 1 of 2 over 2 minus x minus 1 dx plus pi over 4 minus half from part A. which equals negative 2 times ln of 2 minus x from x equals 0 to x equals 1 plus pi over 4 minus half. Applying the bounds of integration, we get negative 1 plus 2 ln 2 plus pi over 4 minus half, which simplifies to 2 ln 2 plus pi over 4 minus 3 over 2 square units.